homework from
And that's
the
definitely
first
true. There's going to be a pretty steep learning curve as we learn these words, right? We've already learned a bunch like array, integer, number, floating point, floats, floor, ceiling, function, a whole bunch of words.
So like for example, like this is an easy one, but so I was able to remember this, but like the uh, remove the F from our alphabet array. So I use the pop command.
Okay.
But if I say I didn't remember, I was like, I don't know, I have zero clue, that it's pop, and I'm just trying to search this. The pop is a method, correct?
Yeah, or function. Yeah.
Or a function
Yeah.
that
So what I would probably search, knowing so you already have the description. It says remove the letter F. Was it F? Remove the
yes.
letter F from your whatever array, right? So I would look for array functions JavaScript. Right? That would be a good search term to get me to the right spot. And then we'll click on here, right? And so I'd maybe just read down this list of all the functions. Okay, so that one removes an element from the array. Let's see, this one removes an element from the array. Add or removes elements from an array. So it gives you like a starting point. If you know that the name of the thing that you're trying to work on is an array, then I would search JavaScript array functions or JavaScript string functions, right? Because that's like the base, and it's in the description of what it's asking you to do.
Okay, that does make
And
sense.
then
It's
you'd
just
you'd still have to click on it to read how it works. But W3 Schools is really great about this, where they'll be like, this is going to remove the last element of the array, and it gives you a pretty concise little example where it's telling you, hey, this is going to remove the word mango. And if that's not what you're looking for, right? If you had to do something else, then you'd go back to it and say like, okay, well, what of these functions will get me to where I'm trying to be? And eventually, over time, hopefully, I because this definitely happened in the last class as well. Like by the time we're in week 5, 6, 7, 8, you'll just inherently know, hey, I need to remove an element from the array. I'm either going to use pop or unshift, or pop or shift or splice, or you'll have a really solid grasp of all the different terms that we've learned so far, and it's just repetition, right?
okay. So methods and functions, there are known methods and functions, but we can also create our own method or function, correct?
Yeah. So like these ones, for example, these are methods in the array object um, that are available to us by default in JavaScript. So we're learning kind of the default. This is sometimes referred to as like the standard library, or depending on what programming like this is the standard language functions that exist to everybody. Each and every one of these we could write ourselves. Right? There's nothing magical happening here because all the really cool stuff that we need to be able to do to program any of these would be, can we loop and can we do ifs? Like let's take pop as an example, right? So array.pop. Let's make an array, right? Var r equals what was it? Apple, banana, and grape. Right? So we have an array with 3 things. We know that we can call r.pop, right, and it's going to give us grape, and it has changed the array. Okay. If I wanted to write this function myself, let's make this be the same thing. I could write a function that says like r.pop that takes an array. Okay. And inside this, right, we could do var new r equals empty array. And right, so I can loop through it for var I equals 0, I is less than r dot length I plus plus. Right, so I'm going to loop through, and we're going to learn about loops today. So this is good practice for us. Right, and so if I'm in here, right, I could say the new array, right, if I is less than r.length minus 1, right? So if we're not at the end already, we are going to add this new r dot push ri, right? So we're going to start at the 0th element, which in this case apple. It's going to say, are we at the end of this array? No. So add this to our new array. Then we're going to get to the next one. Banana, are we at the end of this yet? No. Add it to the next one. Then it's going to get to grape, and it says, are we at the end of this yet? Yes. So it's going to skip over this step. And the way pop works is that it like changes the main array and returns the value. What we're going to do probably, just to show this off, because we can, other languages implement pop in different ways, right? We're just going to simply return new r. We're going to put this in an array of its own, right? So new r is the first element, right? It's our array that has been changed, and then we're also going to say r dot length. R dot length. Okay. So I'm returning an array that is going to have the first element of the array is the new array, and the second element of the array is the one we took off. And so if I do if we look at r, right, that's our array of apple, banana, grape. And if I call r pop here, r pop, and I pass in r, it's going to return an array with, now it's apple, banana. Ooh, and I didn't, I typoed here. It says length. Right? So I have to fix my code. Right? R length minus 1. Right? So get the last element of the array. Right? And so now it says, here's the new array, and here was the one we took out. Some programming languages, when you call array pop like this, they do. They do preserve the original array. R is still here in place, but we have the ability to say R equals R pop, right? R 0, right? So we're going to take the original array. So now R is apple, banana. Now R is apple. So we've implemented R pop on our own. But it came to us for free from JavaScript in a pretty beautiful syntax, so we don't need to do that. But nothing in here, nothing in JavaScript is overly complicated, except some of the like audio libraries and being able to work with video cameras and stuff. Some of that's wild. But all the default functions, all the default methods in our standard set of library functions are fairly trivial, right? And some of that, right, like what I just did, where I implemented a version of array pop, is the exact type of thing that software, that companies like to use as interview questions, where they'll be like, you're working in JavaScript, how would you implement a pop function that would simulate the array pop method? Because it's like a short little contained bit of work, and if you can describe what you're doing, you saw it was really like 5 lines of code for us, like that's the sort of thing that companies love to use as interview questions, just to make sure you know how to code, you know how to communicate, you know how to think through problems that maybe you haven't thought of before. That's a real fun one. Any questions about that? No? All right. We are going to learn loops today. We are going to play with some really cool built-in iteration methods. But what I think I'm going to do is I'm going to jump to the end and start talking about like product design in terms of building something for real with JavaScript. And to do that, we're going to use the homework from last night, which is the rock, paper, scissors game. Where was that at? Right here? Cool. So I'm gonna copy all this, and I gotta go to edit. Edit. Perfect. I'm going to copy all these instructions, and we're going to build this together. But I'm going to use more advanced techniques, maybe some of the ones that we haven't learned yet. But we're going to start talking about like this is how we would build things. This is how you actually make functional cool programs that do interesting things. So we will use this as our example. Any questions before we jump in? All right. So first off, the instructions tell us to make a new file called app3.js. This is assuming that we're working in the week 4 folder. I'm gonna do something a little bit different. I'm gonna create a brand new project from scratch. So I'm gonna open a folder, and let's call this Paper Rock Scissors, PRS. Okay. And I'm gonna select this folder. So we're starting from a blank project, right? There's nothing in here. We're gonna build everything from scratch. So first thing I'm gonna do, I'm gonna make a file called readme.md. I'm gonna paste these instructions in here so we don't lose them. Okay. Good. I'm also gonna make a JS directory, and maybe I'll make a CSS folder. I don't know if we're gonna style it, but it's good to have a structure in place so that if we do want to make some CSS files, we can have a place to put them. All right, so this is good. That's good. So I need to make an index.html file, index.html. Okay, and I'm going to use just our little boilerplate thing here to create an HTML template. I'm going to say paper, rock, scissors. Funny question. Who here calls the game Paper, Rock, Scissors, and who here calls the game Rock, Paper, Scissors? Which one, Selena? Let's do...
Yes.
Okay, let's do a show of hands. Is it Paper, Rock, Scissors? Everyone who thinks it's that, raise your hand. Okay. And everyone who thinks it's Rock, Paper, Scissors, raise your hand. 1, 2, 3, 4. So it's 4 versus 2. Now, I have always heard it called Paper, Rock, Scissors. And when I hear rock, paper, scissors, I both get angry and I feel like people haven't thought through this very well, right? Why should it be paper, rock, scissors? Because this is freaking alphabetical, right? B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. Paper, rock, scissors. It's alphabetical. I grew up in the North. We always called it paper, rock, scissors. When I came in the South, everyone's like, oh, it's rock, paper, scissors. I'm like, that is just wrong completely on every single level that you can name a thing. Anyway, so it's paper, rock, scissors for my project, but you can name your game whatever you want, whatever you choose to do. All right. So let's okay. So looking at our README, I'm going to press Alt Z, Alt Z, so that we get word wrapping here. And I'm going to pull this into a tab so I can look at the examples. All right. So we got an HTML file. We're going to create a file called let's just name it what it says, app3.js. And I'm going to include this in our program by saying script source equals js app3.js. Okay, so we're all caught up. I'm going to pull this into here. So we have code, and if I was to pull this up, right, I'll give myself an H1 in here, so I can paper, rock, scissors. Okay, great. And if I pull up, I have a, yep, there we go. Let's open with live server. So we got our page, right? Everyone kind of can get to this point pretty easily, I would imagine. Okay, so first step, it says create an object with the name of game. So I'm gonna, like, we can even at this point, let's paste these in here as comments, right? We can work our way down. Right up to here. Oop. Copy. And we'll do paste. And let us turn everything to comments, right? So create an object with the name of game. So I can say var game equals, right? It's just got to be an object. So empty object, done. The game object should have two properties. It's win and loss. Okay, so both property values should be at 0, right? So knowing that this is saying this should have two properties, right? If I was to follow this line by line, like for the homeworky purposes of this, I could come in here and say, var game equals, right? And as I get each instruction, I could fill it out. Also, because this is an object, I can come in here and say game win equals 0, game loss equals 0, right? That satisfies criteria number 4. But what I'd probably do with this kind of instruction is I would combine these two requirements, and I would simply do this as a property with this format, this style of writing code. So I would say win 0, loss 0. Oop, there we go. Both properties are 0. Okay. Next, it says create an array named choices. It's going to have rock, paper, scissors. Apparently the previous instructor of this course did not follow the alphabetical rule, so we're going to fix that for him here in our instructions. So we're going to say var choices equals paper, rock, scissors. Good. Okay. Then we're going to have two variables, random 1, random 2. Each variable should be equal to the random number between 0 and 2, right? So we can do var random 1 equals math.floor, math.random times 3. Okay, we just copy this line of code and name it random 2. Okay. Create two more variables, bot1 and bot2. Okay, so in this example, it's saying we're going to create var bot1 equals choices random 1, var bot2 equals choices random 2, right? And at this point, right, where we're up to where we are, we have code. This is all valid JavaScript code. We have our server. I can pull this up in our developer console and just check to see what these values are to make sure I'm making no mistakes, right? If I'd had a typo in here, right? If I had a, like a semicolon, right? This would cause an error to show up in our console. So here we are. I might look at random 1, what is that? And what is random 2? Okay, they're both 2 in this case. So if I look at bot 1, scissors, bot 2, scissors, right? That's what we expect. If I reload this page, I should expect to see different values. Oh, did I? Bot 2, bot 1, yeah, so bot 2 in this case got rock, bot 1 got scissors. Okay, so everything seems to be working up to where we're at right now. Next, using if, else, or switch statements to determine who's the winner. Bot 1 was the winner, set the property of win. So in this example, it's saying bot 1 is like our main character, right? So the object that we're tracking here, this game object, is counting his wins or losses. Bot 2 is who we're playing against, the opponent. Okay. So next, using if. Okay, so we can just simply do exactly that. If so if bot 1 was the winner, okay, determine who's the winner. So we know the rules for paper, rock, scissors, right? Like paper covers rock, paper loses to scissors, paper ties with paper, right? So we can say if bot 1 equals paper, right? So that's step 1. So if bot 2 equals scissors, right? Game dot loss equals game dot loss. It says to set it to 1, so we'll follow the directions exactly. So we'll say game dot loss equals 1. Else, if bot 2 equals let's say rock, right? Now we need to set game dot win equals 1. Okay, so that's paper's taken care of now, right? Any other scenario, right? The only other option here would be if bot 2 had paper. That's a tie. We don't set either of them to 1, right? So we can keep writing this. So we'll say else if bot 1 equals rock, and then the other one is else if bot 1 equals, oh, got an equal sign here. 2 equals scissors. Right. So structurally, like this if block here is pretty good. Right. So we'll just copy that down. And let's give ourselves a little bit of breathing room here in this. Okay. And then all we'll have to do is just go in here and change the logic, right? So when it's rock, if scissors is thrown, you win. Right? So let's keep the structure. I like keeping the structure. So we'll say loss always goes up top, win always goes at bottom. So how do you win as rock? Or excuse me, how do you lose as rock? Paper. Right? And how do you win as rock? Scissors. Okay? And then if you have scissors, how do you lose as scissors, right? Rock. And then paper. All right, so we've just implemented the entirety of the logic of the 3 outcomes that can happen here. Okay? Cool. So then it says create a variable named results. So we're going to say var results equals empty string. Okay? So write an if statement to check if the win property is greater than 0. Right? So if game.win is greater than 0, should append the value of the bot variable to the results variable. So it would say bot1, okay, that makes sense. So we'll say if game.win right? We can just check game.win. It says greater than 0, right? I could say greater than 0, or I could say if game.win has a value at all, right? We'll say results equals bot1. So bot1 plus beats plus bot2. Okay, so that's the winning condition. Then it's saying write an else if statement. So we're going to combine this. We're going to combine these two because this is like the whole line of code, right? So if you lose, else if game.loss results equals bot1. We say should append the value of bot2, right? So it says bot2 beats plus bot1, right? The other thing is that I'm just noticing just now that like bot1 is going to say paper, rock, or scissors. Bot2 is going to say paper, rock, scissors. So even if you win or lose, it's going to say something beats something. We probably want to say, we probably need to include like some message if you won or lost, right? Wins plus loses. Sad face. Okay. Else results equals tie game. Okay. Then all we have to do to finish this out is console.log results. Everyone following along? So now every time I load this page, right, we're either going to win, lose, or tie. Right? We won, paper beats rock. Rock beats scissors, we lose. Paper beats rock, we win. Tie game. Everyone tracking so far? Now, if we had not fixed this problem, right, because the instructions here are bad, they're not explicit, they don't tell you anything, right? This, if you wrote exactly this line of code, these lines of code, you would have successfully completed the homework. But part of being a software engineer is realizing when the results don't, or when the instructions are not clear or don't point you in a direction that is useful. Because if we took out that stuff and we load our page, right? Rock beats scissors, paper beats rock. I don't know who's winning or losing. Was it bot 1 or bot 2? Who knows? Any questions about this? This is the specific homework. So now we're going to turn this into an actual game because we have it kind of written as a game, and it's like super duper close, right? So, where is my code editor? There we go. So let's go back into our index.html, and let's do some stuff in here, right? We'll say input type equals button. Right, we need 3 buttons. We need a paper, a rock, and a scissors. So we can pick what our choice is, and we're going to play against the computer. So we're going to say input type equals button, ID equals paper, and we'll say value equals paper. Paper. Okay. We need 3 buttons, right? So we'll say rock, scissors, paper, rock, scissors. Okay, so we should see, 3 buttons. Now, we haven't learned this yet. This is something we're going to learn next week. There's a couple of different ways to capture user input, right? The first and most easy one, this is like not the correct way to do things anymore, but this is like how JavaScript was written for like the first 8 years, is to come in here and say onClick, right? And anything we put inside the onClick attribute is going to call some JavaScript, right? So if I said alert hello, right? When I click this button, it alerts hello, and it will do that over and over and over again. Okay? So knowing that we have an attribute here called onClick where we can write some code, I'm going to write a function. I'm going to create my own function called play game, and I can, I could pass in paper, right? So I'm saying play game paper. Okay? Now play game paper doesn't exist yet. right? We should get play game is not defined. But I can do the same thing for each of these. On click equals play game rock. On click equals play game scissors. Okay? So now the buttons are clickable, but we have to write the code. So we already have some of the code because we followed the instructions in the homework. So let's just come in here and start from the top. We'll keep the game object. Okay? So we'll say function play game, and then we need to pass it a parameter, choice. Right? That's our argument. We're going to either send it paper, rock, scissors. So instead of, right, we can actually, let's wrap this entire thing, right? So, bloop. Perfect. So all of this code that we wrote that is perfect here, right, would work perfectly inside of a function called play game, right? So when I click play game, the only thing that needs to change is instead of me getting my random choice here, and instead of saying bot1 equals choice is random 1, I can simply take this out and say bot1 equals choice. So I'm going to call this function when I click a button, and I'm going to pass it paper, rock, or scissors, so I don't need to have bot1 be randomly selected. I'm going to be bot1 now. Okay? So I'm bot1. And so now, if we leave this open, paper beats rock. Rock beats paper. I'm on a roll. Scissors beats paper. Nice. Scissors beats rock. Wait, scissors can't beat rock. So we've got a bug. We'll have to track this down. All right. So these are the choices that we can have. If bot1 equals paper, so let's just let's start debugging this as if we didn't know any better, right? Let's say console.log choice, right? And I'll say oh, I know what the problem is. Do you guys know what the problem is? Well, let's keep debugging this, right? So choice. Let's make sure we're good. Paper, tie game. Paper, tie game. Paper, paper beats rock. Paper, paper beats paper. How can that be? And it's because our game object has never been reset at the end of our thing, right? We have win equals 1. And so as soon as I get a loss, right, our game object is just tracking 1 and 1. So when it gets to this part of the code down here, if game.win or if game.loss or tie game, we lose every time. So let's do this. We need to go in here and say game.win equals 0, game.loss equals 0, right? So every time we click the function, we're going to reset our winning and loss tracking. Okay? So now, if I click paper, scissors beats paper, we lost. So maybe that's the next thing we need to do, right? We need to say, we need to go back to saying plus you win, right? And then maybe down here plus you lose. Okay? So now we lost, scissors beats paper, tie game, we beat rock, win, you know, scissors beats paper, we lose. Okay? But you'll notice, like, we're doing this all in our console. That's what the instructions told us to do. But when we build products for our users, like, you've never used Facebook and it said, like, click on this button and open your developer console to see if clicking the button worked, right? Like, developer console's for us. Our users are expecting to see things happen in here. So let's go back to the drawing board here and let's design maybe some nice and beautiful. Let's make this a little more interesting. So the first thing I want to do is, this kind of jumps out at me, is these are our buttons. This is what we click to make the game work. So let's maybe come in here and wrap this in a div. Let's say div class equals game controls, right? And we will indent these a little bit, right? And now I think, yeah, let's definitely add some style in here. Let's combine some of the stuff we learned previously. Link rel equals style sheet. href equals CSS. Let's just call it app3.css. Okay. So I'm going to make a style sheet, new file, app3.css. And the first thing I want to do is I'm just going to do .game controls. And maybe I do border 1px solid black. and maybe I give it a nice like light gray background. Color is maybe let's do like DDD maybe. Yeah, good. And maybe what I want to do is width 250 pixels. Let's just, yeah, good. And we'll do padding 15 pixels all around, right? So we got ourselves a nice little box here. Maybe what we want to do in here is say, H2, make your choice. H2. Oh, got to save. Right, cool. Then, right, this element, if we were to inspect it, right, the H2 has some margin around it. We want to probably get rid of that. So let's come up here and let's say, and we'll do it underneath. Game controls, H2. So any H2 inside of game controls, we're just going to say margin 0, padding 0, right? So that should, yeah, much better. And maybe what we want to do is actually have margin bottom of like 5px. So there's a little bit of space between our word and our buttons. Everyone tracking so far? We're just doing some lightweight styling. It's not the prettiest thing in the world, but we're starting to like set this up as a game. Maybe the next thing I want to do in here is have results, right? I want to have, let's make it a div class equals game results. Div. And maybe what we'll do in here is we'll make another H2 and we'll give it an ID of results. So this H2, whenever we click the button, right, whenever we make a choice, right, we write it in there, this results thing. So instead of doing console.log results, we do document.getElement by ID results .inner HTML. And we're going to learn about inner HTML formally next week. Inner HTML equals results. Right? So now I click this button, and we get to see our message here. Okay? So we're on the right track. We have a game results. I probably want to do some styling here with the game results, so I'll maybe do game results, and let's just give it all the same styles as game controls. But I know I'm going to want this to be a little bit bigger, so maybe let's make this 450 pixels. Okay, perfect. And then I think I want this to be floated. Float left. Right? I don't want to mess with Flexbox or any of the grids or anything just yet, but maybe we will later, right? So I can make them kind of side by side like this. And then for this one specifically, I want to add margin left. Let's just do 10 pixels. Right? So now I've got a little bit of space between our things. And then this one, right? Game controls H2 is where we took away that margin and the padding. This is an H2 as well, but you'll notice it's pushed down. So what I'm going to do is I'm going to use this same rule, game results H2, so that both of them have the margin and the padding taken away. So whenever I click a button, right, I should see my results here, whether I win or lose. Okay? Now, as a part of this, right, maybe it'd be cool to see my history, right? So as I type in result, as I play the game, I get to see if I win or lose. So let's do that now. So I've got my results, H2 there, that's where I actually put the results. Then I'm going to create a UL. I'm going to say past results. Past results. Okay? And just by default, it's going to be empty, right? When we load the page, right? Maybe what we do is we start this off with game results. Game results is empty. We haven't played any games yet, but if I click scissors, right, I want rock beats scissors, you lose to go on a UL, so that as we play more games, we get to keep a running track of what we're doing. So I've got an unordered list here, and as we are writing our results in, maybe before we do this, right, we say, bar past result equals document.getElement by ID results .inner HTML. And when I'm calling this .inner HTML element, this property here, on the element is saying, hey, any HTML code that is inside of this, give it to me. And if we set it to something, it's like we're writing HTML to the page, right? So if I was to come in here and say the past result is that, then I need to grab a reference to our unordered list here. Right? So I can say document.getElement by ID past results. Okay. So, and I need to save this to an element, right? So I'm going to say list. I'm just going to call it past results. Results list. Past results list. So this is now going to be a variable that has a reference to that element. Okay? A reference to that unordered list. And what I need to do is create new list items. So I can say, I got an even easier one. We're not going to learn about creating dominoes that way. So this is what we'll do. This is better. So I'm going to simply say, whatever the inner HTML of past results is, .inner HTML equals, and I'm going to put in li plus results plus close the li, okay, plus whatever was in there before, right? So as we click the play, as we run this play function, we're going to create a new li and put it inside this unordered list with whatever was in there before. So the most recent result will always be at the top, okay? And so now if I click scissors, right, tie game, scissors beats paper, you win, right? And now we have a list going on down the screen. Pretty cool, huh? We've made a game in like, what was this, 30 minutes? Now, if I was going to make this a real beautiful game, I would probably continue to iterate and tweak. I'd make, maybe pick a nice font. Maybe I would choose to, clean up this list, right? Rather than just saying you win or you lose, maybe I'm actually storing the results in an array, right? Because we have this game object. We have this game object up here, right? This would be a really great place to put in a past results array, right? And just store a list of all the things we've ever picked. Then, when we learn about back-end development, maybe what I want to do is store my entire history in a database so we can see who is better at picking and beating computers at paper, rock, scissors. This HTML page is the starting point of building a really cool actual game, right? Like paper, rock, scissors is a simple game, obviously. But we can use this type of technology, use this same type of randomization to be a jumping off point to help us understand everything there is to know in all of software development. And as you saw, right, you guys should be at the stage where you could theoretically, following those instructions in our homework, be able to make a game like this. So think about it like, what if I said to you tomorrow, without giving you instructions, hey, build me a tic-tac-toe game. Build me a coin flipper. It goes heads or tails, and you try to pick if it's going to be heads or it's going to be tails. Right? It's the exact same kind of thing, right? You could write out the list of steps. First, I need to get a random choice. Is it heads or tails? Then I have to have some buttons. Do I pick heads or tails? Then I need to store the variable. Then I need to say, did I win or did I lose? And if you take, 10-foot step back, right? This is the exact same technology that you would write if you wanted to make something more complicated, like blackjack. If you can pick a random number between 0 and 52, right? Like, which card did you draw? Okay, what's the next card that was drawn? Is the value of those two cards put together greater than the value of the two cards that we randomly picked for the dealer? The only thing that we haven't really covered yet is all the buttons. Like, we should be able to, and we're going to learn this next week, write better code than this, so we don't have to put an on-click in our HTML. Because really the correct way to do this would be to come in here and say, document.getElement by ID, what do we call it, paper, add event listener click function, right? So this is the formal, correct way to add event listeners. This is the old 90s way, 1990s way to write event code. Okay, it's the same thing, and you're going to learn all of this next week as we continue to explore and continue to get better at JavaScript. But there is absolutely nothing in this homework that we did today that within an hour or two you couldn't make something really nice and really cool and interesting. And then the more time you spend polishing it, right? I'm not super designery, but you could pick a nice background color for this. Maybe you can make it so that you got different fonts or different padding. Maybe you have a table of how good you are over time, right? So right now we have this list, but it would be like cool from a game perspective, thinking like what would be neat to see as a user, like what is my win percentage? What is my win percentage when I pick paper? What is my win percentage when I pick rock? What is my win percentage when I pick scissors? That's just math. That's counting. Count up all the times I picked paper and all the times I won with paper. There's our win percentage. Because we can create variables, because we can create arrays, because we can create objects, and we can put stuff on the page, right? This is really the inner HTML is really the only thing we haven't really started to cover, but this lets us write to the page, and then when we learn how to actually make things clickable, or how to say when a thing is clicked, JavaScript is going to do something. Now we can build full features web applications. The HTML and CSS set up the page, set up what it looks like, and then JavaScript lets us make it do cool things. We literally built an entire paper rock scissors game in what? When did we start? 4:10, so 40 minutes. That's pretty good. Now I know all of the words that I wanted to type, so it went quicker for me. But you should theoretically be able to do this in 2 hours, even if you had to look up all these lines of code. How many lines of code is this, right, from top to bottom? It's like if we took out all of our comments, like 5 here, 6, 7, 8, 9, 10. Right, let's take out all the comments and let's see. Cool. So yeah, for like 70-ish lines of code, 64 lines of codes, and we get an entire game. And all of these lines of code are the ones that we've been playing with all week. We're not doing anything crazy. We're getting a random number. We're deciding who won, and we're using an if block to compare. Any questions? Go ahead, Olivia.
So when you made that event listener thing, do you use that for like people that do tagging in Google, like to record like if someone clicks confirm?
Yes.
Okay. Okay, cool.
Yeah. We're going to learn all about events next week when we start learning the DOM. But essentially, like Google, when you're talking about that, right, they might have an event listener in there that says document.getElement, or they may even say document.body.add event listener. Right, so you want to watch every event on the page, and it's click. And then we say function this, or event, right? And so they will say console.log event dot client x plus event dot client, right? Like whatever event, like Google or whatever is tracking each and every one of these events. They're tracking mouse movements. I'm sure you guys have seen that analytics where they like, hey, this is your heat tracker where all your links on the left. That's where everyone's clicking on. Right? They just have big event listeners. I'd have to do it to let's see. Document. Let's just add the whole document. Right. So every time I click, right, that's where those are the x and y coordinates. Oh.
Okay, because it was like a few months ago. One of the agencies was telling me I needed to create a like confirmation page instead of, after they hit submit, it just says thank you for submitting. They said they couldn't record the event that way, that it had to be its own page.
Yeah, And that's just,
Okay.
that's some stuff that like Google is maybe Google Tag Manager, Google
Oh,
specific.
okay.
Yep. With however they wrote their analytics library. But essentially, document.add event listener or document.get, like we can add event listeners on every, like we can add it on the entire page and see what happened. Like you'll notice that I'm clicking, my event listener is running and telling me the coordinates. But as I click scissors, right, it's still giving me the coordinates, but now my code is also running for a thing. So you can have event listeners on top of event listeners so that like multiple things are happening. And we'll cover that in great detail later. Cool. Any questions? Any other questions? All right. It is 4:55. Let's take our first break. Come back at 5:10. Loops are, as we've kind of shown, the way you make things happen repeatedly, right? So we're looping through some set of criteria, some set of guidelines, and we're going to do something over and over and over again until some condition is met or we tell it to stop looping, okay? Let's start with a for loop, because we've been playing with that. We've been playing with that for a little while. So a for loop. Now let's make a new JavaScript file in here. We'll call this loops. Loops.js. Rename. Good. All right. So let's take some comments in here so that we can follow along. I will check all of this code, including the paper rock scissors stuff, into GitHub so you guys can refer back to it, because we'll try to keep this as clean as possible. So a for loop, right? A for loop is probably the most basic or the most default type of loop that you'll ever use in your entire career, right? For loops exist in some form or another in every programming language I've ever used, and if not like all of them, right? The only exception maybe be like toy programming languages where they're intentionally doing something like, for kids where maybe they don't have this type of syntax. But for loop is like your go-to, pull it out of the toolbox, it's great. And the way a for loop is structured is that it's just like other things, right? It's the keyword for, then it's the parentheses, and we'll talk about what goes in the parentheses, and then a block, right? So curly bracket, curly bracket. Every time the for loop runs, all of the code inside of this block will be executed, right? Unless we skip over it, right? So just like everything else, it creates a block of code for us to execute. Now, the structure of the for loop is as follows, right? Inside this thing. It's three separate sections. The first is a declarative section. The second is your exit condition. And the third is your iterator, right? These are like some terminology, lingo for you to start to know. So in the declarative spot, right, in our for loop, we're going to declare our iterator, right? So for var I equals 0. It doesn't matter what we name our variable, right? This could be n, this could be j, this could be x, doesn't matter. By tradition, if you're in a for loop, it's generally a good idea to call your variable I, because I is short for iterator. And the reason you want to make this one letter, if possible, is because you're going to be, hopefully, our common use case for this is we'd have an array, and we've been using this all over the place, and we're going to say ri equals something, or we're going to do something with ri, right? So we want to have what we're typing inside of our block of code be short enough that we don't have to type 50, like if I'd made this like iterator, right? Now every time I want to use this in my code, I've got to type out the word iterator, right? So by tradition, most of the time, we call this I. Okay? If we were going to do another loop inside of here, right, for var, right, because sometimes we have to do two loops, you can't use I because it's already used. So then generally what people will do is they'll do something like J or K, right? So just go to the next letter in the alphabet, right? If we were doing a multi-nested loop, right? This would let us write our code to say like R-I-J equals something, right? Each of those is the iterator, is the iterator that we're going to be doing something with. The next thing that happens in a for loop in this section up here is the exit condition. And you've seen me write this a couple times in examples. We're going to say, we're going to run the code in this code block until this exit condition is matched. Right? So it's going to say I is less than 10. Or I is less than 1,000. Doesn't matter what your exit condition is. This is where we put it. The third and final section is our iterator. So we're going to say I++. Now I++ is shorthand for I equals I plus 1. There is also an I minus minus, which is shorthand for I equals I minus 1. Plus plus and minus minus are shorthand. It's called an incrementer or a decrementer, right? It's going to increment by 1 or decrement. Now that word sounds silly. Decrement. I don't know. It's going to either increment it or decrement. Whatever the other word is. So generally, we write our for loops like this. We're going to say for var I is I equals 0, I is less than 10, I++. And if we were to just simply come in here and say console.log I, go ahead, exit condition. Exit condition will run until it is true or false. It will run it while it is true. So in this example, and we'll show this off here, let's load our code. Let's put it in here. Let's take out app3.js and let's put in loops.js. Okay. And if we come to our page, right, you see that I is 0 because we declared it as 0. I is 0. So the first iteration of that loop says console.log I. And it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now when it gets back, when I is 9, the next time this loop goes up here, it's going to say, is I less than 10? And the answer is no, so it leaves. If we had put in here I is less than or equal to, right, less than or equal to, we could put them both in here. Now it will go 0 to 10. 0 to 10. We also don't have to start at 0. We could start I equals 5. Right? Now it goes 5, 6, 7, 8, 9, 10. We can define our variable to start wherever we want, go as long as we want, and we don't even have to use this shorthand, I++. I can say I equals I plus 2. Right? Now it goes 5, 7, 9. If we move this back to 0, right, now it's going to be even numbers. 0, 2, 4, 6, 8, 10. Or we could do I equals I plus 3. 0, 3, 6, 9. Let's do this. This will be more fun for us. We can look at them both together. So we can change this in any order or structure we want. As long as we say, this is where we can declare a variable, this is where we check to see if it's still going to continue looping, and this is where we do something. None of this is required, right? So I can take out this. Let's make I up here, right? Let's say var I equals 0, right? I don't have to put any declarations in here. I can just put a semicolon and say skip it. I don't even have to include this, but we're going to include it now just so we can show this off, right? And then we can also, right, we don't have to increment. If I was to run this code right now, it's going to run forever. But what we can do is we can say I equals I plus 1, right? We can write our code inside of this block. So every time we loop, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because this line of code is causing the increment. We don't have to include any of these things in here, right? And one of the things that you'll sometimes see, especially in video game programming, where they just want to have an infinite loop. Maybe they'll write something like this, where they'll just say, run forever. Okay, this would run literally forever. If we wanted to, we can say if I is greater than 10, or greater than 9, well, let's just say if I equals 10, break. Right? You guys remember break from our switch statements yesterday? Break also works in loops. Break, what it does is it says whatever block I'm in, leave that block. It's how we got out of the switch statement. If we use it in a loop here, writing break here, right? 0 through 9, as soon as we get to 10, it breaks. This is kind of complicated code. I would not expect you to write a for loop and not put anything up here in our for loop section, and then write it in here manually. This would be kind of a code smell. If I was, your boss, or if I was working on your team, I'd be like, "Why did you write your for loop like this? That's silly." But just know that you can. Just know that you can. Generally, what you do with a for loop, and this is how I write them all the time, is you just kind of don't rock the boat too much. You say, I'm going to declare my iterator in the first spot. I'm going to put my exit condition in the next spot, and then I'm going to do my incrementing in this last spot. Okay? Also, it doesn't even have to go this direction, right? I can say for var I equals 10, I is greater than 0, I minus minus. And now it's going to count down from 10 to 1. You see that? We can go in either direction. We can go any number of, like, if I made this 100, right? Now it's, or 1,000. It's going to count down from 1,000. Look at all that. If we made it 55, right? Anything we want to put in here, the for loop is our best friend. All right. Any questions? Let's change this back to the basic, right? So we'll say there. Go ahead.
For that last condition where it's minus minus, why does it have to be 2 minus? What is the importance of 2 minus or 2 pluses?
This is the shorthand, right? It's a shorthand incrementer. It's the exact same as saying I minus 1. It's just shorthand programming lingo. You'll see this in a ton of programming languages. JavaScript, C, C++, PHP, Perl, Python, Ruby. They all use this exact same syntax, where if you do a variable that has a number in it, right? If we say 1 plus plus, var I equals 1, right? I plus plus, I is now 2. If we do I plus plus, I is now 3. It just means, it's just a shorthand to let us do I equals I plus 1, or in the case of minus minus, it's the shorthand for I equals I minus 1.
So if you do 3 of those, 3 pluses, will that do anything? Will that use the same logic?
Error.
Okay, so it's just 2.
Yep, it's just a special. Yeah, see, my console won't even let me run it because it thinks I'm trying to keep typing math. Go ahead.
So basically the I plus plus is you're just adding 1, and then if you say I equals I plus 2, then you're adding 2, and then 3, 3.
Correct. All that matters is that in the third spot of our for loop, knowing that for loops are, for declarations, exit condition, and incrementer, right? All that matters is that in the incrementer spot, you could put any math you want to operate on any of the variables, right? It doesn't even have to be this variable that is declared here, right? We could do J++ or J plus 7 or whatever we want. We just get to put math in here so that every time this loop runs, it's going to change some variable that we have defined in here. Okay. These are also, I think it's important since we're talking about this incrementer and decrementer, right? This is the post incrementer, right? When it's I++, we can also do plus plus I, which is going to add it to the number first. And there's like complicated rules here, so that like if you were checking something, you wanted it to add first. This would add it before it completes other things in the equation. Just know that if you see plus plus I or I plus plus or any number like I can do age equals 37, right? Age plus plus is going to make age now equal to 38. Okay. Plus plus age, right? It's showing you kind of what it's doing here, right? So when I type age plus plus, it is setting the value of age to 38, but it's showing you that it's returning 37. If I do plus plus age, it's setting the value of age to 39, and it's returning 39. So it's doing the math before it returns versus doing the math after it returns. It's just shorthand. I could have just as easily written age equals age plus 1. But that's way more typing than age plus plus. Right? And now age equals 48. Okay, so that's a for loop. Any questions about for loops? Generally, for loops over arrays. Generally, what we use for loops for, this is like the number one go-to thing, right? We don't often write code where we're just counting numbers, right? There are better things to do with our time than count numbers. We usually use for loops to iterate through arrays. So we'll say var fruits equals, let's say apple, banana, grape, strawberry. Okay, so we'll just make a little array here. Right. Generally, what we'll do, using that same syntax, where we say the declaration is here, the exit condition is here, the incrementer is here, right? Generally, we will write our code to say for var I equals 0, right? Because all of our arrays start at 0. I is less than fruits dot length. Okay, I plus plus. So that's going to say, however big this array is, we're going to start at 0 and count all the way to the end, incrementing one spot each time. And then we'll do something with our array. We'll say console.log fruits I. Okay? We are using our I variable that we created right here that is changing every time this block of code runs. And we're saying, hey, show me what's in the fruits variable. What's in the fruits array? So now you see apple, banana, grape, strawberry. Okay? That is the number one use case for a for loop, is looping through arrays. That's why the syntax is set up to support this. Like, it should be very clear to you, knowing that arrays start at 0 and go to some length in the future, that this for loop is the perfect way to describe I'm going to loop over an array. Okay? Now, what if we had a multi-dimensional array? For loops over multi-dim arrays, right? So let's say we had a var students equals array, and we're going to make this multidimensional. So each element in this array is going to be a student with a, maybe first name, last name. Okay? And let's just, I'll copy this a couple times, right? So we'll say Meg Harrison, Isla Harrison, right? Just going to put my family members in here. Dexter, right? So if I was to, do the exact same thing, var I equals 0, I is less than students.length, I plus plus. And if we do console.log students I, okay, let's take this out, right? You'll notice that it's logging an array, right? Each one of these lines is an array. If I wanted to loop through the elements of that array, we would have to write a second loop inside of it, right? So instead of doing this in console.logging students I, if I was to write a second array, I can come in here and say for var j equals 0, j is less than students I dot length, j plus plus. And then what we're going to do inside, can I make this smaller? Just like that, perfect. Then I can do console.log students I j. Go ahead.
If you click the file thingy on the side, it'll make that whole thing go away.
Oh, perfect. Thank you. So what this is doing is that if we start getting in the practice of running code in your head, right? So let's walk through this together. So we start out, we say, I'm going to declare a variable named I and set it to 0. And I is going to run until, we're going to run this loop until we get to the end of our students array. And then we're going to increment our I counter every time we run this loop. Then we go in here, and there's no code in here. We took out this console.log. But the very first line of code is it says, hey, let's make another for loop. So j equals 0 now, and j is less than the array inside of it, dot length. right? We've included students I here, right? You notice this one is just students.link. That's the top level of array. And then students I is the element inside of it, right? Each element in students is an array itself. And so if I was to come in here and put in Eric Ryan Harrison, right? Ryan Harrison, the instructor, right? Now it's going to loop through record 0. Then it says, hey, J is now 5. So it's going to say Eric, Ryan, Harrison, the instructor. And then J will no longer be less than students I.length. And so it says J++, and then it leaves that loop, and it goes back to the first for loop. And then it says I is now 1. So it moves down to this one. And then it says 0, 1. And then it moves down to this one. 1, 2, right? So this is multi-dimensional arrays. It's an array with, it's a for loop inside of a for loop. We could do, if this had, right, if we had a, another array in here, right? 1, 2, 3, 5. In theory, we could write a third for loop inside of this one. We just make a new number, right? For var k equals 0, right? K is less than students I j dot length k plus plus, right? Do something cool. Now, if we were to actually run this code would break because not every element in this for loop is an array, right? But what we can, right? Maybe we can show this off, right? You see it gets to Meg Harrison and then it still displays the array. Let's do console.log students I j k. And so now it's causing all kinds of problems for us because each element, right? We learned this about strings yesterday. Each element, if it is a string, it's going to here. It's going to the first student. And then it's saying go to the first element, right, Eric? And then it's this third loop is saying go through this element character by character, right? Because strings have a dot length property as well, and then display it. What we could do is we could say if type of students I j equals, right? What is our array equal to, right? Let's say type of array object equals object, then do this, right? So now we're only going to do this third loop if it reaches an array in our thing. So if we save this out, now it works perfectly. Eric Ryan Harrison, the instructor, Meg Harrison, then it gets to an array, it runs this line of code and displays that right here. Then it says if this element is an object, or in this case it's an array, right? JavaScript objects are, if you run type of it, counts it as an array, or counts it as an object. If it's that, then loop through all of those elements as well. Everyone tracking? Let's take that out though. Let's go back to being clean. Cool. So this is a multi-dimensional array using for loops. For loops are your best friend. You should think of them as like one of the first things you probably want to do most of the time. Go ahead, Josh.
I'm kind of having a hard time understanding the multi-dimensional loops, the exit condition. So J is less than students I.
Let's see if we can use our browser and maybe make it a little clearer. Let's see how can we do this? Perfect. Let's go to our. So I'm in the sources tab. I'm gonna show the loop. I went and clicked on the loops code. So I'm gonna put a breakpoint right here, and you make a breakpoint by just saying you just click on the line number. It's gonna show that there's a breakpoint there, and let's see if we can't watch what's happening. So let's do it. Okay. So now that there's a breakpoint there, I reloaded the page, and it stopped right there. So it's showing us where we're at. So right now I is 0. If we hover over it, it shows you what it can get to, right? Students, it's showing you, like, you can hover over each of these things, right? And see what the current value is. So this is 4. So while I is less than 4, I plus plus, okay? So these controls over here let you step over or step into or go line by line. So we're going to press, and you can also use F9. So we can do F9, and you can see that it's stepping through these conditions. So now we can see that I is 0, I is less than that, I plus plus. And so if we look at, now it's saying students I, right? And you can just walk through the code here and see that it says Eric. And then it's in this loop again, and now it says Ryan. Right? And you can even go to the console. You can see this happening as we go, right? So now it's students 4, right? We can see that this whole value is Harrison. And if we press F9 again, right? V. And now it's done, because 5 is how many elements were in that array. It's can we watch? Yeah, let's watch some of these. Yeah. So I clicked this little watch tab down here. We can also add. Let's watch J. Can we watch J? Watch J. Right. So now I is 1 this whole time. Now I is 2. Now I is 3. You see that happening while we step through it? Oh, now it's now step out of. So it's, how do I explain this? So we know that our code goes from top to bottom, right? Okay, so in this case, this is the very first, this is what tells the JavaScript the interpreter, hey, I'm going to be a for loop. And I'm going to set up some variables. I'm going to set up I for myself. I'm going to say, hey, while I is less than, in this case, 4, right? While I is less than 4, I plus plus. Then it runs each and every line of code in here. But now it gets to another for loop. So it goes here to here to here to here. Then this for loop takes over, because this is a nested loop. It's inside the other one. So then it's going to go tick 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 back like this until J is less than students I dot length, right? So it's going to run 5 times to that first one. 5 times to that first one. Then it says, okay, I'm done. And then it goes back up to here. And it increments I. And so now I is 2. And then it goes back to here. This is something that maybe you will just get better with when you write a few of these yourself. And the best way to look at this, right, we could do console, here, let's show this off. Console.log students I. And maybe what we need to do is just console.log I. And then in here, console.log J. Right? And I still have the breakpoint in there. Right? So if I run this, this is kind of the flow, right? I starts out as 0. This is the first element of I. Students I is this entire array. Then it goes down to here. Now J is 0, right? Maybe we'll do this. J equals plus I equals plus. Right, so we're in the first loop. I is 0. Then it gets, this is the element. Then it goes to J. Then it goes J1, J2, J3, J4. And once this inner loop exit condition, right, as soon as J is not less than students.length, it goes back. It goes to the end of our thing, and it goes back up to the 4. We can say console.log restarting loop, next loop. Right? Does that make more sense? This will get easier with practice, I promise. Okay, so that's a for loop. This is kind of your default, this is your go-to. We also have a while loop, right? And a while loop is kind of similar, a little bit simpler. And what they do, what it does is you say while, and then the condition itself, and then it's the block of code that's executing, right? And so generally it's while this condition is true. This is a single Boolean thing to check. So like while true, right? Do something here. Okay, so while loops, because they're simpler, right? We don't have an iterator. We're not declaring variables in here. We're just generally checking something like while let's make it an so while age is greater than 0. Okay, so let's make an age variable. Var age equals 37. Okay, so if I was to just run this loop right here and do console.log age, it will run literally forever, and the browser window will get angry. Yep, I can't even. It crashed my Chrome. But what we can do. Oh my goodness, it really did crash Chrome. That's annoying. What we're responsible for doing with our while loops is we're responsible for doing our checks or our iterators or whatever inside of it. So if we're saying we want this while loop to run as long as age is greater than 0, then we need to be responsible for saying age equals age minus 1 or age minus minus if we want to write it in the shorthand way. Really, I'm going to have to close this. I'm going to kill the whole process. This might actually kick me out of the Hangout. I should have planned ahead better before getting myself into an infinite loop. I regret my choices. Can I make a new? Nope. That's broken too. Alright, I'll be right back. If I can even close the terminal. Oh no. Let's kill Google Chrome here. No. Goodbye.
So how was everybody doing?
And we're back.
You're muted.
Oh,
You're muted. Oh, I have to take over as presenter for myself. Oh gosh. So be very careful when you're writing code with loops, because if you do not have an exit condition, the loop will run forever. This is called an infinite loop. Okay, and it's such a funny thing, and it's such a prevalent thing that you will do as a programmer that I got an infinite loop tattooed on my arm. Okay, infinite loop is when a loop never exits. Okay, so back on our code, let's pull up right, developer tools. Perfect. So if I open up here, all right, let's reload the page. Right, so you can see this is the age. Starts at 37 and it loops its way down to 1 because that is what our while loop does. It says while some condition is true, do this thing. Do it forever. Whatever's in this block of code, run it forever. And we are responsible for making this condition eventually be not true. Okay? That is a while loop. Does anyone have any questions with this? It's the same, all of these loops do the same thing. They're all looping. It just depends syntactically how you want it to appear. Like, do you prefer this code? Right. So even this example, right? While age equals 37, I could have written this for loop version as for var I equal. I can even do age equals 37. Age is less than or is greater than 0. Age minus minus. Okay, and I can do console.log age. Right. These loops are doing the same exact thing. And if we were to save this code right now, right, it's going to loop from 37 to 1 2 times. The reason you would do a while loop instead of a for loop is syntactically, if you're trying to show off that, like, maybe you have more complicated results here, right? So a for loop, this example, we're using one variable, right? We're saying while the age is greater than 0. But generally when you would use a while loop, real example, is you would say something like var run while true equals true, right? And we would say while run while true, and then you have some complicated code that has a bunch of exit conditions, and maybe it's like, you know, until user pushes a button, right? Or until you know, 1 hour passes, right? So you might have a whole bunch of complicated things happening in this loop that eventually would get to a point where it would say run while true equals false. So it will run until something crazy happened, whereas a for loop by default is just kind of operating on one specific value. We use while loops all the time in video game programming. You will say, while the game is running, play the game. The game always has to run because we're responsible for drawing our menus, we're responsible for running physics, right? You would be, and until the user presses escape and pulls up the menu that even shows up in front of it and says exit game or exit to desktop, the exit to desktop is the thing that says turn off the game. But inside the while loop, we're doing all kinds of things. We're doing, you know, calculate physics, right? Run physics, update timer, you know, like check AI, or like a run AI loop, right? So you might let the bots or the artificial intelligence do some stuff. All of that has to happen each and every frame of the video game, right? So every time, and then the final thing would generally be like render game, right? So this will loop forever. It's going to render the game after it has calculated the physics to see, you know, where's the ball going to be in this frame. Update the timer, right? How many frames per second are you seeing? Run the H, you know, pick what the AI is doing, and then finally it says, okay, now that we have a new world state, let's display it using our graphics card. While loops are great for video games because you got to do a bunch of complicated things in there that you want it to run forever until the user specifically exits. Right, I'm going to comment all this out. So we have it in our code. All right. Comment that out. Good. I'm going to comment all these console logs so we stay clean, but I'm going to leave them in here in the comments so that when you go back to like look at these as a reference, if you choose to do so, you'll be able to you can just uncomment them and see what you want to do. Any questions about while loops? They're much simpler than for loops. It's while this condition is true, right? If we do while true here, it runs forever. If we said while false, it's going to always never do anything. It's going to skip right over it. Right? Because this will never be true. If I was to say, here, let's show that off. Right? Run while true is true. So let's say console.log inside the while loop. Right? It's running one time, and then it gets to run while true, and it sets it to false, so now it's false. If this was false to begin with, it skips over the entire thing. Everyone tracking that? The final built-in kind of default type of loop that we're going to look at right now is the do while loop. Okay? And the do while loop is very similar to a while loop. It starts with the keyword do, then it has a block. Then at the end of the block, it's the same sort of syntax: while, run, while true. Okay? And I'm reusing this run while true variable because I want to show off the example here. Console.log inside a do while loop. You'll notice that even though run while true is false, because we just set it to false, the do while loop runs the loop at least once. It will always run whatever is inside this block one time, and it checks to see if we're going to exit the loop at the very end. The while loop is very similar, but it checks before it runs. So if the condition is false to begin with, no code in the block is ran. A do while loop always runs at least one time. And you would use it the exact same way that you do with the other types of loops. You are responsible for your exit condition. So you could say console.log inside the second do while loop. Okay? And let's make a variable. Var do counter equals 0. So we can do counter plus plus, or we could do equals do counter plus 1. Same syntax, just slightly different looking. And we'll say while do counter is less than 5. All right, so this will run 0, 1, 2, 3, 4, and then it'll exit. Or then it'll run a 5th time, right? Do counter. All right. So you can see this was that first do while loop. Let's take that out. Let's take this out. Okay? It's running this line of code inside the second do while loop. Then it's incrementing the counter. So now, then it's going to log it and it's going to say, hey, now the counter is 1. Then it goes 2, and then it goes 3, and then it goes 4. But if this was, while do counter is less than 1, right, it's never going to be true, but it's still going to run it at least once. The do while always runs the block code one time, at a minimum. Everyone tracking? All right. It's 5:50. Let's take a break. Come back at 6:05. So we have some more looping things to look at that are even crazier. All right, recording good. All right, a few more things to show off in regards to loops. And I'm assuming everyone else is back with their cameras off, eating a sandwich. Cool. So, we want to talk about 2 special keywords that we use in loops, right? The first is continue. And what continue does is continue will immediately jump to the start of the next iteration, right? And so let's show this off with a while loop real quick. While, let's make a variable, var n equals 0, right? While n is less than 10. Okay. If we were to write in here console.log n, okay, right? If we run this code, we will see. Did I? Oh, I infinite looped again. Dang it. Okay, let's n equals n plus 1. All right, I'm gonna have to reconnect. I will be right back. Stupid loops. Loop day is always going to catch me. I guarantee it. All right. Okay, so where were we? So we wrote a loop where we're just saying, console.log n, and at the bottom of the loop we're saying n equals n plus 1. Okay, so if we were to go to our terminal, right? Let's take out all these other ones. Good. Good. Where's this other one come from? Oh, here. Cool. So it counts up 0 to 9 because we're saying while n is less than 10. Right? If we made this less than or equal to, it will count up through 10. But we have a continue keyword that says, hey, skip to the next version. skip to the next loop. And so if I was to come in here and simply say, if n equals 5, continue, right? And what this is going to do is when our loop is going through here, it's going to say, n is 1, goes to the next loop, n is 2, goes to the next loop. When it gets to n equals 5, then that's true. It's going to go inside this if block, and it's going to run continue, and immediately not run any of the rest of these lines. Oh, that would cause an infinite loop too. Ooh, I'm glad we caught this. So let's do n equals n plus 1, right? If we continued here, as soon as we got to 5, it would go to the next loop, n is still less than 10, and it would keep going forever and ever and ever. Okay? But because we put this here, or one thing we could do is we could move this up to the top, right? So it will always count. Then if n equals 5, continue. Otherwise, print it out, right? So if we save this now, you can see it goes 1, 2, 3, 4, 6, 7, 8, 9, 10, 11. Everyone tracking?
Could you explain that continue one more time? Why did it skip 5?
Because we said if n is 5, continue. And what continue does, the reason we're showing this off here, continue immediately stops executing the rest of the lines of code in this loop and goes back to the top of the loop. So when n is 5 here, it's the same as if we said, hey, just jump back to the top. Okay. If we said n equals 5 or n equals 6, right? Or. That's the or we learned yesterday. Now it's going to skip over 6 in here. Or n equals 7. Right? Or we could say if n modulo 2, right? Now it's skipping any odd number. Because remember, modulo is, what is the remainder? Continue. It's going to skip over any other lines of code that are in here, right? We can even, I could put console.log skipped, right? That will never fire. If I put this above, right? Skipped, 2, skipped, 4, skipped, I could do modulo 3, right? Now it's just showing the powers of 3, or the ones that are divisible by 3. Continue is a keyword that will let you keep running the loop, but stop, further lines of code in this loop if the condition matches. Let's continue. There's another control structure that we can use, and we talked about it earlier, right? Let's use the exact same thing, right? Let's go back to if n equals 5, right? Let's take this out. And that control structure is break. Break immediately leaves the loop. Right? Continue will continue the loop, but just right back at the top. If we use break here, right, even though we said while n is less than 10, as soon as we get to 5, break is going to leave the loop completely. And you can see that here. It goes 1, 2, 3, 4. Boom, out of the loop. It's the same exact syntax break as what we used to get out of our switches yesterday when we're done with a case. It's the same thing here inside of loops. It says leave this block of code. Everyone following? Break and continue. And all you have to do to use these is just write the word continue or write the word break and put a semicolon in. No other arguments, it's not a function. It's just the actual keyword break or the keyword continue. Alright, let's comment these bad boys out. Now, we were looking at for loops up here, talking about we're going to use it to loop through arrays, right? But what if we wanted to loop through, how do we loop through objects, right? So let's say we had an object that was var students equals, and we say, first name, Eric, last name Harrison, right? Age 37. What if I wanted to loop through this array, or excuse me, this object, and display the values in here, right? Let's try it with a regular for loop and see what happens. For var I equals 0, I is less than students. Like, students even have a .length property? No, because we didn't create one. Right? So how would we loop through an object? Like this wouldn't even work, so I can't even show you that it would fail. All right, we could loop through object.keys students, right? We learned object.keys yesterday. It's going to give us an array .length I++. Right? And then we would have to say, console.log, right? If we logged object.keys students, right? And then we have I here, so we could do I, right? That should log out each key individually. Yeah, first name, last name, age. So we could have taken this line of code as we loop through it and say console.log. If we wanted the value, object. We could do students, console.log, students, I. We'd have to do object.keys students I, right? This is annoying. But there's a better way. JavaScript knows that we're going to want to sometimes loop through objects like this. So they gave us a really cool loop syntax called for in. Okay? And what this lets us do is say for var key in object. So for var key in object. It's still a for loop, but you'll notice this for loop doesn't have the semicolons in it. It's just, this is specifically for looping through objects. And what it does is, as we loop through each and every one of those elements in this object, it's going to give us the key. It's going to put in this key variable, right? We can name this whatever we want. We can name this as, prop, whatever, key. And so what we can do here is we can say console.log key plus key plus, I'm just giving us a little cutesy students key, right? So the first time it goes through the loop, it's going to say the key is first name and the value is Eric. The second time through the loop, the key is last name and the value is Harrison. And then its key is age and then the value is 37. So for in is how we loop through objects like this. Any questions about this syntax? If you're looping through a regular array, you want to use this syntax of a for loop, because we need the index, right? We need a number, because traditional arrays are indexed by number, but objects are indexed by a string, a key, a property. Okay. And then the last type we're going to take a look at is there's a special method. Let's grab our fruits array. Right? All right, and this is the array.forEach. Okay, and array.forEach takes a function as its argument, and this is super wild. So you just let me write a little bit of code, and we'll try to explain what's happening. So if I do fruits.forEach, it takes a function, and what it gets in here is the value as its thing, right? And we don't have to call it, like, whatever we put is the argument here is what we're going to have inside this function, right? So I can put element here, right? I can do whatever I want. Whatever name here is the variable name that we will have inside this function. And if I say console.log element, right? What for each is going to do is every element in this array is going to get passed individually to this function. For people who like JavaScript, for people who like this style of, because we're going to use, this is like using a callback function. We're going to say, we're saying, hey, I'm going to pass you a function, and you're going to do something with this function over and over and over again with each individual element, right? A lot of JavaScript will be written in this format, where you say, I've got an array of elements, right? And a good example of this, right? Let's do document dot get elements by, let's do query selector all, right? Button, right? So that's going to be an array of all of our inputs, right? This is an array of all of our inputs. People that write lots of JavaScript love for each because they can take this array and chain it for each, because this will say, el console.log el, right? Because the return of query selector all, which we'll learn about next week, is returning us an array, or in this case a node list, but that's an array. And so that array can be chained with for each, and we can pass it to a function. We will play with more of those types of things over the next week, right? Because sort works the same way. Yeah, I mean, we took a look at sort earlier, right? Like sort was the one that was in that Kahoot game the other day we did, where we said we'd cover it later. There are a lot of functional functions like this that take a function as its argument and apply each element in an array or each element in a list or to that function, like this. So that's for each. So that is kind of like the fifth way you can loop through things in JavaScript. We've learned the for loop, which is kind of our default loop. We learned a while loop. We learned a do while loop. And we learned a for in loop for objects. Dot for each is a method, is a function that exists on arrays that let us pass in a function and do something on each element. Any questions? And this is the syntax for that. You will see each and every one of these loop types used interchangeably on almost every project you work on. Before I gave you guys I said, hey, whenever you're working on a project, just pick one thing and pick one style and follow it from start to finish. These loops are used interchangeably based on where you are in the program, what you are trying to work on. If you're dealing with database records, you might be doing a while loop. So you could say something like when we get into the back end, right? When we're making queries to the database, we might say while db dot fetch record. Oh, come on, don't do that. db fetch. Right? So this would be like an object when we get into the back end side. There will be like a db fetch function. So as long as there are records, give it to me in my code. Then you'll get an array of users and you'll loop with it for the for loop. Then you'll be on the front end writing JavaScript to make buttons work, and you'll use .for each. These types of for loops will be used interchangeably based on what is the best type of loop to use for that specific situation. And if you've got a big enough program, rock, paper, scissors is a terrible example because it's a small program. But when we start making really complicated apps, when we start making complicated websites and programs, you should be choosing to use the right type of loop for whatever situation you need to iterate through. Does that make sense? Okay. Who has any questions about loops? Let me save my code. Let's take out the broken DB loop. Right, this one doesn't work here. Good. Any questions about loops? I'm going to check in this code into GitHub. Let's make a GitHub new. Let's put it under here, and we'll say paper, rock, scissors, and loops. Cool. Make this public. I'm not going to put anything in here because I'm just going to copy this, right? Good. And so I'm going to create this now kind of the backwards way. So I need to say get init, get remote add origin, shift insert and paste that in here. Do get add dot, get commit dash m, initial entry. And we'll do get push origin main. Now, all of our code is here on GitHub for you guys to look Paste this into Slack. Any questions? Go ahead, Josh.
Can you quickly? I don't want to harp on this, but the for loops. I'm still really hung up on the nested arrays and the multi-dimensional for loops. I think I'm saying that correctly. That second for loop, that condition is still. How do you read that? So I understand conceptually like that is going to read an array within an array, but I just don't know how you get that. So for variable j equals 0, so it's going to start off 0 and count up. And then this is where I kind of get hung up. So students I dot length, that's, what is that? That's just the array length. Isn't that the same as saying students dot length?
Students I, because we've looped through it here the first time, right? Students is this array, right? It's each element. That's element 0, that's element 1, that's element 2, that's element 3. When we're in this loop, we're saying loop through the entirety of the students array. That's the top level array. So students 0, students 1, students 2, students 3. Right, if we took out this inner loop and we just console logged students I, right? Let me take out all these other console logs. Sheesh. Sheesh. Okay. So the first loop is what we've been doing, a single dimensional array, right? We're saying, hey, loop through the student's array. This is element 0, this is element 1, this is element 2, this is element 3. Okay? Right? We're tracking with that, right? That part's simple. This next loop, we're saying, is inside this loop, right? And we created a new iterator, and you'll notice here that j is less than students I, which is this element by itself, dot length. So if you look at student, like this is the first iteration of that loop, right? It would go, okay, now this is an array. And I want to loop through each element of this, right? So students, this one is a length of 5. So it's going to go 0, 1, 2, 3, 4, 5. Right? It's the exact same thing as this, right? If you imagine that this first loop is looping through an array, this second loop is looping through an array also. It's doing the exact same thing. It's just that the array that this one is looping through is the element from the first loop.
Okay.
So every time this loop happens, it's moving, imagine like a little pointer. It starts here. This is the first element. This is element 0. Loops through that, and it passes it to this for loop that now has to loop through each individual spot. Now execution moves to this one because we're done with this one, and then has to loop through each individual spot. So just kind of picture in your head like a little, you guys ever do like karaoke or something where each line, like karaoke is a great example of this, right? Because in karaoke you'll have like a var song equals, something, right? Here, let's, how can I do this? Yeah, I'll do it. Perfect. Okay. So each line of the song, let's use it as an array, right? Okay. This is line 1. Jingle bells, jingle bells. Right? Jingle all the way. Right? And as you're going through the karaoke machine, this is like on screen 1, right? First, you're going to bring up line 1. Then it's got a little red ball that'll go jingle bells, jingle bells. Then it goes to the next line, jingle all the way, right? As you go through that. That's what this multi-line loop is doing. It's just saying, give me the first line, and then loop through each individual element. Then give me the second one, and loop through each individual element, right? So all we're doing is we're combining a concept we already understand, looping through an array, and we're saying loop through the array that's inside the array. Does that make sense? Maybe it would help if you
Yeah,
explained it.
so that makes sense, but so say J equals 7.
Okay.
And then the array that would be in line 7, say it's only has 2, or like let's like for your example, Dexter Harrison.
Mm-hmm.
That only has 2. It's only a length of 2, but it's on line 4.
Mm-hmm. So the part of
Wouldn't
that
that
is
make that
maybe,
false?
yeah. So
4 is
every
not greater
time
than.
it runs this loop, the top loop, right? It gets down to here. It declares J as 0. This line right here says J is 0. Then it says J plus plus. So it goes 1, 2, 3, 4, 5. Then it gets to the next line because the loop has restarted back up to the top.
Oh,
J gets set back to 0.
okay. That's where I was getting hung up on.
Yep.
That makes
This is
sense. That makes
declaring
sense.
J to be 0. And then J, student's I, right? It starts at 0, and then it goes to 1, then it goes to 2. So this is looking at a different length each time, right? These can all be separate, something. Right? These can all be separate lengths.
Okay.
Yeah, good question.
That makes sense.
I'm glad that you asked these clarifying questions because we breezed through this last time, and then we found out like in week 4 or week 7 that people were struggling with arrays. So thank you so much for asking for clarifying questions. I can only explain it to you the way I understand it, and if there's no questions, then I assume that we're all good. Cool. Anything else? Any other questions? All right. It is 6:30. We have we put together a super quiz that covers like all the stuff we've learned this week, and we're gonna do that next. But we need probably like 5 minutes to make sure it's good. So take a quick break. We'll come back at 6:35, and then we'll spend probably like 40 minutes doing a quiz, and then spend the rest of the evening talking about it and talking about questions, things that don't make sense or things that we're struggling with still. Okay. So 6:35.
Sup, you beautiful bastards. Welcome back to the Philip Franklin Show.
Focus on the ones that multiple people got wrong and just point out the ways that we had some errors. So, cool. So the first one, half of you got wrong because the question asks, choose all that apply. Everyone got the first one correct, right? Everyone got one correct, but some of you didn't put the other one, right? There has to be at least 2 answers. Right? We even tell you there are 2. Right? The other one is let teachers equal. Right? Let is the other way we learned to declare variables and declare arrays yesterday. So I cannot emphasize enough that in programming, like following the directions is the most important thing, right? If you're using documentation from a third-party API, like if they say, hey, you need to put in the number 4 here, you can't put in the number 5, or you can't skip it. Some things are required, and so getting into that habit, getting into the routine of reading the question, reading what's asked of you, and doing exactly that is a super important skill to have because it's like black and white sometimes, right? There's very little gray area. There's a lot of opportunity to be creative and to like operate in the in-between zone for things that are kind of nebulous. But when there's a requirement or when there's a specification, it's a yes or no. Everyone got that one right. Boolean symbol or. Let's go down to the next one that we had some trouble with. All right, cool. did all very good with most of the ones in between here. This one kind of gave everyone a little bit of trouble, right? It felt like a lot of you maybe just did a coin flip and said, is this true or false? The question is, slice selects the elements starting at the given. So like if we say slice on an array and we say, start from 0 and go to 4, right? And ends, but does not include the end argument, right? So slice, if we look at the documentation here, let's go to JavaScript, array slice. Yeah, sure. The slice method returns a shallow copy of a portion of an array into a new array selected from start to end, but the end is not included, right? So if you said, if we have this array of animals, ant, bison, camel, duck, elephant, right? Animals.slice 2, 4, right? 0, 1, 2 goes from camel to duck, right? 0, 1, 2, 3, 4. This is the fourth element, so it's going from here to there, but does not include whatever element is included at the end, right? So slice, when you provide a stopping index, that stopping index element is not included in the return. Okay. Good. Those are the only two that gave everyone consistently some trouble. Everyone, a couple people missed a few of the other ones. Array.split, for example. Or, string.split. How would you split a string into words, right? This split splits the string into letters. This one splits it into words because we're splitting on the space. There's a space here in between those two quotes. Whereas if you split with no space, it's going to split the individual letters. And then the other thing, that we kind of went over this yesterday, but we mentioned it again today. The break keyword breaks you out of blocks. So it's going to break you out of a switch block. It's going to break you out of a loop. Break, just like it describes, breaks the execution. Other than that, good job. There wasn't really anything consistently in the last question where we said, hey, what are the things we'd like to focus on? The common theme throughout this is, just more practice, more repetition. For those of you who wrote something specific, I would encourage you to take time tomorrow for office hours, and we'll spend 30 whole minutes going over anything and everything that you would like to go in more depth. Because, each of you are kind of maybe struggling on different parts of this, and we'd like to focus and maybe come up with some exercises, some examples that are unique or interesting to you. All right, it is 7:15. We got a little bit of time left. What would we like to talk about? We can go some more examples. We can rewrite the rock, paper, rock, scissors game and clean it up. Right. One thing that's really cool. This is true of both English and programming, which is you almost always do a better job on your second write or your second rewrite or your second edit than you did in the first time. Now that we know what our paper, rock, scissors game is, we can rewrite this very easily and make it even more robust or write it in a better way. Sometimes you're going to do something once and then realize halfway through it, hey, I can improve this now that you've got like the big picture. We can do that. We can build something new, or we can just talk. If there's something that we'd like to go over as a group, I'll kind of leave it up to you guys. So group consensus wins here. What do we want to do? What do we want to talk about?
Can we go paper, scissors, rock?
Okay. One vote for that. Anyone else?
Yeah, I'll second that.
Okay. That's a simple majority. Well, 2 of 4, really. So, cool. I just want to understand dates in JavaScript. Yeah, Eric, I think we should probably you should probably schedule time tomorrow. We'll go over that in office hours. Is anyone else struggling with dates or the date object specifically? Okay. Yeah, schedule time tomorrow, Eric, and we can spend 30 minutes playing with it. All right. So right now I have we have our code here. Let's pull this up. Let's take off loops, and let's turn this back to the paper, rock, scissors game. All right. So now we're back to where we were. Right. Everything's working. Okay. So, structurally, things that jump to mind, right? We've got our HTML here. Oh, that's perfect. I'll put it like this so that it's small, right? Cool. Right, we've written this code once. We know that it works, and I know that I probably want to clean this up, right? Because we just took our homework assignment and we really just literally wrapped it in a function so that we could call it from our HTML, right? We can call it from here. But maybe, not maybe, but definitely there's a better way to do this, right? We're storing, we talked about when we were doing this in class, like it would maybe be fun to show some statistics. How often do I win with paper? How often do I win with rock? And with our current implementation, it would be very difficult for us to track that. But we have all of the tools at our disposal with arrays and with objects to maybe start tracking some of those statistics. Maybe maybe we can clean up this code a little bit, right? So let's maybe break this down and write it as a more functional program with more opportunities for us to add new features in the future, right? Because this is kind of from top to bottom kind of, I mean, even one of the things that jumps to mind, like when we write functions, right? When you start getting functions that are 60, 70, 80 lines long, right? There's probably a good opportunity to clean things up, right? Make things a little cleaner. This function is doing a whole bunch of work when really it probably needs to do less work. So let's assume this function doesn't exist. I'm going to comment the whole thing out. But we like the function to be our starting point of our game. Okay? We have a game object. Now we have a past results array. I maybe even want to put this as let's think about this. Let's think about this in terms of like I want to track some statistics. So I can do let's just do paper 0, rock 0, scissors. Right now I want to track my wins, loss, and I want to track my win percentages based on these things. So I'm just going to keep that there as a placeholder to remind me I want to add that as a function. So I still want my function play game with my choice to like kick things off. When I click a button, this function is going to start the magic. Okay? So let's start taking some notes. This is generally how I like to write code when I'm trying to think through like what am I trying to build here. And we did this, we showed this in an example with our homework where I said, hey, like make comments of what you're going to do before you start writing code to do it. So let's say function to kick off a game. Then we probably want to have a function to pick the computer choice. That seems reasonable. Then I maybe want a function to decide who won. And then I maybe want to have a function to save results, right? Like and display them, right? So that's kind of the like from top to bottom, right? We press the play button, we pass it our choice. Then we have to get the computer's choice. Then we have to just say who won between these two things. And then we want to maybe save the results in here, in our object, and do something with them, right? Right now, our game object, if you remember down here, we had kind of a little bug that was kind of annoying, is that our game object was just tracking to see if there was a win or a loss value, and then we had to reset it at the end. So we were losing some of that information that maybe we want to put in there as like, right? If we'd had this be like an incrementer, right? Now we can track win percentage, right? This goes to 1, and then this goes to 2, and then this goes to 3, and loss is 0. It knows I played 3 games. It knows I played 3 games, and I have a 100% win rate. So we can get more information by using our variables more intelligently. But that would mean we need to change kind of the how do we know if we've won or lost, right? And so I think we can simplify a lot of this code down here and make it better with a cool function. So it's 7:21. Let's breeze through this as fast as we can. And if there's any questions or if we want to stop, me, please let me know. So I'm going to just assume that let's write some functions here, right? So let's say function get computer choice, right? So that's going to return a choice, right? Function decide who won. Function get winner, and we maybe put in like player choice and computer choice. Good, that makes sense to me. And we'll return the winner. Okay, and then we need a function to save results. Or maybe we'll do like process results, right? Because it's saving and displaying. So we're picking language. We're picking the names of our variables that describe what we're doing. So we'll say process results, and we're going to probably say player choice, and we'll say maybe result. Right, it's going to be a win or a loss. Okay? That seems reasonable to me. All right, so play game happens. We kick off play game, and it says, we've got a choice in here. Right? It's going to be paper, rock, or scissors. So then we need to, right? We need to get our computer choice from, it's got. We want to have this return paper, rock, or scissors. So let's come in here and say we know my choice. My choice is player is the choice thing we pass into play game, right? And if I was to just console.log this right now, log choice, right? We can run this code, and we should see, right? Paper, rock, scissors pop up in our console, right? We can at any time as a part of this development process. Console.log is your best friend here. Log what's happening. Log what every interaction is doing. Okay? So we know we're getting that, but we probably need to say var comp choice equals get computer choice. Right? So we know that my choice is that. So let's say console.log choice, comma, comp choice. Right? So that's going to log both of these variables. Right? Paper undefined. Right? Good. Because comp choice is not returning anything yet. But we already know that code. We wrote this earlier, right? So we can say, let's make ourselves a little simple array. Var options equals paper, rock, scissors. Okay, and then we need to get a random number, right? So we can either do it this way. We can do var rand choice equals math.floor. Math.random times 3, right? That's giving us our random number. Store it to the thing, and then return options rand choice, right? So whatever number is picked, 0, 1, or 2, is going to return 0, 1, or 2. Okay, but what if we simplify our line? Like, we don't need this extra line of code. We don't need to bring extra variables into this. Let's just say return math.floor math.random times 3. Now it's all one line. Okay? And we can move our comment up if we wanted to keep that comment in there, right? This is kind of a bad comment because it's telling us what is exactly going to happen on this next line. If we write good code, like this to me is pretty good code, you should be able to see that we are returning one of these options randomized between 0 and 3. We've picked good code. So I would maybe even just take out that comment because it's kind of not needed. Okay, so now if we run this code, like pick rock. Did I save it? Yeah, there we go. Rock undefined. Okay, so something's wrong here in our. Oh, it's because I forgot to put the parentheses in my function call. Right. So simple attention to detail thing causes our program not to work. All right, perfect. So now I pick paper, computer picked paper. I pick rock, computer picked rock. Great. Cool. So we've got our computer choice. Now we need to decide who won. So I need to make a variable called winner equals get winner. And I'm going to pass in choice, because that's what our variable is that we are submitting. Player choice is choice here, comma, comp choice. Right? So this is going to give me my winner. So it's either going to be player or computer, right? So maybe we have this say, in our comment, we say player or computer. Or maybe we have it just say it's a win or a loss, right? Because I'm the player. So maybe we make this, it returns a true or a false, or a 1 or a 0, right? True or false. So we'll say true is I win, false is the computer wins. Maybe we change the variable name to 1, right? So I either won or lost, okay? So now I need to make this in here, right? We wrote this code before, but the code was kind of gross, right? It was a whole bunch of if, else, all this nonsense. Maybe we can write this better now that we're a little bit smarter. Okay. Let's just copy the code for now, and we'll think about improving it next time, right? So I'll just come in here and put it like this, right? So this is our original code, right? but all of these variables need to be changed, right? Bot1 is no longer, right? So this is going to be player choice. So I can just change this to player choice. And we can use our editor here to our advantage, right? So I can copy this entire section, go to Edit, Replace. Yep. And we'll just say bot1 replace with player choice. Okay. Let's just go to the next. Okay, so we want to change that one. Yes, what's the change thing? Replace, enter. Now let's just change all of it. That's fine. That'll just simplify everything. So, wait. Change, replace all. There we go. Player choice rock. That button. Then we need to make bot2. We make this computer choice. Place all. And you'll notice I pasted that code we copied into the wrong function. So let's move that. I put it in process results. We need to get this in get winner. Okay? So this is going to return a true or false. We want this to return 1. Okay? And so let's just make var1 equals false by default. So now we can simplify our code a little bit. We can say 1 is false. Oh, we need to probably track ties too, huh? So that's something that's missing up here. Let's say tie 0. So maybe this needs to return, okay, not true or false, but let's say -1 is a loss, 0 is a tie, and a 1 is a win. So we're just kind of inventing this on the fly as we go. So let's just change 1 to result. And we'll make it 0 by default. Okay, so by default we're going to say everything's a tie. So either we're going to win or we're going to lose, right? So we'll say result equals -1. Result equals 1. Result equals -1. Result equals 1. Result. And result. I'm going to make that -1, right? So the return of this function is going to return either a -1 for a loss, a 1, or a 0 for a tie. Perfect. Now we're cooking with gas. All right. So we got the result. Oop. So we get the result here. Okay. So let's just simply store. Right. So we need to store our result, and we wrote a function for this: process results, player choice, and result. So let's just copy this line of code. Okay. And we will put in choice because that's the name of the variable in this function. And the result, we just got it from here. Put a semicolon in there. And that should be it. Right now we just need to write what happens when we call process results. So I'm going to click on this these little arrows. Right? See this little arrow? It collapses the entire function. It just gives us a little bit of extra space here. So I need to do something when I call process result. Okay? So I'm passing the choice, player choice, and I'm passing the result, which is going to be a 1, a -1, or a 0. So the first thing we should do is I want to increment every time I pick a thing here. I want to increment this value. So that's if I pick paper, pick rock, pick scissors, that's going to go up 1. So because player choice is already a string that says paper or rock or scissors, and because that's the exact same thing we named the keys in here, we can do something really cool with JavaScript or with a lot of programming language. We can say, store. Let's write this down. Store the choice in our game object past results. And is that what we named it? Past results. Yep. So I can simply say game dot past results. Okay, I'm using the dot syntax here because past results is a thing we can control. Right? Game dot past results gets me into this object, but now I'm going to use the square bracket syntax here for this object because I'm going to pass in player choice, and now I'm going to say plus plus. Plus plus is the incrementer we learned about today. Right? So it starts out as 0, and if I pass in paper here, it's going to be 1, and it's going to be 2, and it's going to be 3. So that one line of code has made player choice has made it so that we're going to count up each and every time. Okay, that's step one. Okay, now I need to decide if I've won, lost, or failed, right? So I can simply say if result equals -1, okay, game dot loss equals no, you do plus plus here too, right? Else if result equals 1, game dot 1 plus plus. Else game dot tie plus plus. Okay. We probably also, right, because we want to display the results on the page as well, right? Before we were coming in here and we had this this element. Where was it at? Let's just inspect here. Inspect. What is the name of our H2 here? It's H2 results. So I'm going to do that same thing. I'm going to do. Let's just do document. We're actually gonna. I'm gonna teach you guys a little trick here, right? So if I wanted to update this document.get element by ID results, right? That's this H2 that we have right here. This game results H2 dot inner HTML equals lost, right? I could do this for each and every one of these. Okay, one tie, right? So if I save this and I click paper, we've got an error here. 1 is not defined. App 3, line 62. Oh, because I'm still returning 1. What do we call it? Result. Return result, right? So now if I click this, right? Tie, 1, lost. We're updating this. Everyone following along? And that was happening because we're saying document.getElement by ID results. But this is a lot of code, right? A lot of extra crap. So what I would probably do as a developer, I would say var result L equals document.getElement by ID results. Okay. And then instead of saying this each and every time, I would say result L dot inner HTML. Result L dot inner HTML and result L dot inner HTML. So I've just stored a copy to the return of this function, because this is a function. Every time you call getElement by ID, it's going and it's searching for that element. Now I'm saving it, saving the result in a variable, because I need to use it. But now I don't have to look for it each and every time. I don't have to write out that I don't have to write this out on each and every one of these lines. And it would even be more efficient if I was going back and caring about performance, not putting this here, but instead maybe putting it up here. Result L document.getElement by ID results, right? And the reason we're doing this is because each and every time I click a button, this function is being called, which is then going and searching for this element, but the element's not changing. The element's the element. So why not store a reference to this element somewhere else? But now, because I didn't put it in here, I need to go game.resultL, game.resultL, game.resultL. Is everyone following along with that logic? What we're doing there? We're storing a copy. So now if I click this, right? I have to, right? Do you see what's happening here? It says cannot set properties of null. It's because I did not put defer as my attribute. So the JavaScript is loading before the page has loaded. So now I click on this. We do in fact see one lost tie as we go. Okay, so let's take a look at our game object and make sure that it has all the things we would kind of expect to be in there, right? See our game object, we had loss, one lost tie. We should change this to lost, because I used lost down below. And that's like past tense, right? So lost. So if we click this a bunch of times just to verify where everything's working, then we look at our game object, we can see that we've lost 1, tied 5, won 3. Oh. I did the same thing with win, didn't I? Let's make this all past tense. Perfect. lost 7, tied 2, won 7. So, not bad. Not bad. And then you can see that our past results, we're tracking that I've picked paper 5 times, picked rock 3 times. But maybe what we want to do is we might even want to think about, if we care about the statistics of our game, we might need to track, like, I asked paper 5 times, how many times did I win with paper as well? So we might even have to say, like, paper win rate. Or maybe we want to put that in a separate object so this one stays clean. So we can say, like, win rate. Paper 0, rock 0, scissors 0. Right? And I forgot an S here. Scissors 0. Unexpected identifier. Oh, got my comma. Right, so now our game object would be ready to go. Right, so if we wanted to start storing information in the win rate, right, we can come in here, just like we said, game.passResults player choice plus plus. We can come in here and say, for every time we've won, just in the, we won this, right? We can say game.passResult, or not past results, win rate player choice plus plus. So now, if I click scissors every time, let's see how often we win with scissors. Just with scissors. Okay, game. And we can see now that we have lost 10, tied 15, won 11. And see, we won 8 with scissors. That doesn't make any sense. We picked scissors 33.
Line 2, you have 1 as 3.
What?
Check out line 2.
Line 2? All the way up the top? Oh, why do I have 3 in there? That's weird. I must have hit it on accident. Oh, cool. Anyway, so as we click scissors a bunch of times, game, right? Now our numbers should add up correctly. Lost, tied, won. We've won 5 times with scissors, and we have played 11 total games. So we could do that math now, knowing that we have played scissors 5 times, right? How do we find the percentage of win? Right, it would be like 5 divided by 11. Right? So 45% of the time we win with scissors. So we're off to a really good start. And now all I would do at this point, I'm very happy with this code. It's at a point where I've got everything broken up so that the main function calls a couple of other functions, and we've got all of that logic separated into their own little buckets. So as I add new features, as I want to add new functionality, I can do that here. Like, the next step to me is, like, I think this function, process results, is probably going to end up doing too much stuff, because we also have it displaying our win, loss, tie information on our page, and we also want to we probably need to have it start displaying some of our statistics that we're starting to catch. So we probably would think about, and let's write ourselves a to-do, consider splitting out the display results into its own function. So this is the process of software development. You start with an assumption, you start trying to solve a specific problem, you iterate a little bit, you write code, you test it, and as you get better, as you start building more and more stuff, right, this code is all, we don't need this anymore. It's all gone. We've improved it into, it's still about the same amount of lines of code, right? There wasn't a huge change here, but it's structured much better now so that we can start adding statistics, we can add features, and each of these functions is smaller in scope. It does one specific thing. And now we're tracking statistics. We can tell how many times we've lost. Now, here's a question. It's like kind of a bonus question to start thinking about development creatively. We are doing math.random up in here, where we're determining our options. What would we do, or how would we make the computer favor one of these options over another?
Type important.
What was the question, Karif? What did you say?
You type important.
Type in a fourth option? It's kind of hard to hear. You have a lot of background noise. What if we wanted this computer to pick paper more frequently than these other things? Because we're just picking a random number, right? It's going to in theory, if you hit this 1,000 times, you should see, 333 paper, 333 rock, 333 scissors. We know that's not really going to be the case, just because randomness is random, but it'll be close. If you put it on like a chart, right? The more times you chose, the more normalized it would get most of the time. So
I had a question kind of going along this. So we have the variable options, paper, rock, scissors, and then it's getting it's randomizing that. But how? So you got the math.floor or the randomized, function right there. How does it know to assign that to, like, if it gets a random number of 1, how does it assign it to paper? Or we didn't assign like paper equals 1, rock equals 2, scissors equals 3.
Because it's in an array here. So what we're generating
So just
is
got
an array,
it,
is a value, right? 0, 1, 2. And we're returning options. Like this is the array. So we're saying,
could you put just more paper, like up at the top, make paper
Yeah.
more,
yeah, that's exactly right.
or
So
whatever?
if we wanted to, right, we could say paper. Oh, so now he would be, 50% of the time he would pick paper, 25% of the time he'd pick rock, 25% of the time he'd pick scissors. Now, this is what I was kind of getting at, is that you could now build a more interesting type of computer. Right? If we wanted to actually make this game interesting, we can build real AI into this, all inside this one function, right? So now we've just said, hey, paper is going to be picked more often, right? So I should win more games if I pick scissors, right? We should expect to see that I win more frequently with scissors. And if we check game now, I have won 13, and I've lost or tied a smaller amount. So if I picked paper again, right, now paper's even more heavily weighted. Paper, right, let's make this 5. Okay. Scissors. So this number should start to get even more obscene the more options we put in for paper. So if you look at game, I won 18 and I lost. So I'm winning more than 50% of the time now. Okay? Now, you'll notice that I keep changing this number every time I make options go up. What could I put in here instead of the number 5 that would make it so that whatever choices I put in this array, it's always going to give me a random number between this the total size, instead of having to change this every time. Is there a way to get the total number of items from this array?
Is it the dot length?
Yeah, that's exactly right. Options dot length. So now, as I keep adding new items in here, paper, 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 right? Now I never need to worry about changing this value. I've just made my code better. It's more robust now. And if I hit scissors a bunch of times, I should expect to win a whole bunch of games. Right? If we look at game, yeah, I won 24 and I lost 11. We are so much better at the computer than at this game. Okay, so we figured out that we can kind of stack the deck in our favor, or we can at least change the weighting of these elements. What if we wanted to make the computer smarter? What if we wanted to make this game more intelligent? What are some things we can do? What if we want it to beat us more often? Who's got any ideas of how to get better at paper, rock, scissors? what are some like psychology strategies that we could do? Maybe it's maybe we could have the computer pick whatever would beat our last selection as a player. So if I pick paper, the computer is going to next time pick scissors every time, assuming that maybe I picked the same thing twice. Maybe that would increase our win percentage. Or maybe the computer could pick whatever beats what it lost to this time. So if I picked paper and the computer picked rock, maybe now it's going to assume that the player next time is going to pick something that can beat rock. So it would pick paper. So maybe now the computer should pick scissors, thinking that the player might change to beat what the computer just did. Maybe we should do 2 or 3 of these strategies at the same time, right? Part of the joy of programming is we get to decide how much effort and energy we put into solving these types of problems. So maybe what we end up doing is we create a couple different functions, get computer choice 1, get computer choice 2, where we have a couple different algorithms that are picked from randomly so that the computer changes its strategy. Or maybe every time you play, you end up playing the same computer over and over again. You got a bad player, you got a good player, there's a hard, medium, and easy, right? All we'd have to do is just write another function, right? And we can say get paper lover choice, right? And maybe the paper lover never picks scissors, right? Options equals, paper, scissors, paper rock. Right? Those are the only 2 things paper lover will do. And then he can, same code, right? Return this. And then our code can choose when we play the game, right? Who are you playing against? What algorithm? And it mixes and matches because the computer now, as the programmer, we represent the computer. We're trying to beat the player. So we can start getting really interesting at how much fun we put into this game. Go ahead, Josh.
Can you walk through just really quick, the conditional statement there?
Which one?
Right below it. Yeah, right there.
Okay.
So it's saying if player choice picks paper, but I don't see like a if then state, like there's no then right underneath it.
The then.
If player choice equals paper, yeah.
The then is what is executed in the block. So if player choice is paper, the then is all of these lines of code. Otherwise, if player choice is rock, the then for that is all of these lines of code. Everything inside that block. And you can kind of see this with our, right? If we collapse all of these are the if statements. If player choice is paper, or if player choice is rock, or if player choice is scissors.
Oh,
then
I got it.
is the lines of code that go inside of it.
Okay. That makes sense.
What do you guys think? You guys all ready to be game programmers now? I started programming when I was 11 because I wanted to make video games. And then I did that for a career and I realized that's not as much fun as it sounds. It's way more fun to play video games. Cool. Well, it's 7:51. Are there any other questions? Would we like to go over this anymore, or is there anything that didn't make sense? I would encourage you to schedule office hours tomorrow to talk about anything you want in depth. More than happy to spend as much time as we need. Does everyone know how to schedule office hours with the Calendly link? Cool. One thing that's kind of cool about Visual Studio Code, I've kind of not showed this off because it annoys me more than anything, but it's really useful when you're building big programs like this, is that when you write when you write some functions in here, right, you'll notice that it's showing you the right, player choice here. It's saying when you hover over process results, it's saying it wants you to put in a player choice, and it wants you to put in a result. And what this any means is this is the type of value that you're sending. So because JavaScript by default is untyped, right, it's saying any. It's going to take a number, it's going to take a string, it's going to take an array, an object, it doesn't know. And then it's telling you here what happens after the colon is what it returns. So this returns nothing. Process results just does them. But if you look at getWinner, for example, getWinner is returning a number. So it's giving you a little bit of information so you don't have to scroll up and down all the time. getComputerChoice is telling you it returns a string. You guys see that? When it says void, void is like a C or a C++ type of thing. Just think of that as saying it doesn't return anything. We don't have a concept of void in JavaScript, but the text editor doesn't know what we're doing, just is being helpful. Right? Here's a great example. It's saying getElementById is going to return an HTML element to us, and it gives us even some helpful text. Returns a reference. Right? This is a part of the documentation. Any questions? Good job this week, everybody. We made it through week 4. This is just scratching the surface of JavaScript. Next week, we're going to be super hard and heavy into using JavaScript to update web pages, to make requests to our pages using Ajax. I think we cover some APIs and stuff next week. It's going to be super fun, and it's going to give you more opportunities to play with loops, dates, JavaScript objects, arrays. We're going to do all of it. It's going to be super fun. We're really getting into the good stuff now. Go ahead, Eric.
Yeah, can you hear me?
Yep.
Okay. So I'm actually learning JavaScript along with you guys. I made this little whack-a-mole game from this tutorial I've been doing. And I got the code on GitHub, and I'll share the link with you guys. I can show the show you what it looks like if you guys want to see it.
Yeah. Share screen.